Hi guys, welcome to our channel. My name is Felicia and this is my assistant.
Hi, my name is Aisha.
Hello. We're going to be doing an experiment, the noble gases experiment. We love them because you'll see why. They're so cool and brightly colored. The noble gases, they have the outermost valence electrons, so they don't need to attract any more electrons or donate any. That's why they're so cool. Every element wants to be just like noble gases. And here are some info.
The noble gases are odorless, tasteless, and colorless.
Their melting point and their boiling point are so close to each other that their liquid state is only in the short temperature range. So some noble gases have their differences between 3 degrees Celsius or 5 or 7. Again, as mentioned, they have 8 outer valence electrons, therefore they are the most stable elements in the periodic table. They have no electronegativity and no electron affinity whatsoever due to the fact that they don't want to attract any more electrons.
They are satisfied with complete valence electrons.
Exactly. Noble gases are usually inert, but as you go down to the periodic table, the ones that have the higher atomic number are a little bit more reactive than the ones in the lower atomic number, such as helium. This is the reason. The reason why is because they are more. Their electrons are so far away from the nucleus. Compared to the ones in compared to helium, or helium or neon, whereas their electrons are so close to the nucleus that the nucleus can still attract the electrons, making the bonds tighter. Today we're going to be doing the noble gases, except radon and oganesson, due to the fact that they are
dangerous due to their radioactivity.
all the noble gases are not naturally occurring, with the exception of oganesson. First, we're going to be doing an experiment with helium. So helium
has the atomic number of 2 in the periodic element.
The melting point of helium is negative 272.2 degrees Celsius, and its boiling point is negative 268.9 degrees Celsius. It was discovered by Jules Janssen in 1868. He was observing the sun and he noticed a yellow line along the solar sun. And he knew that was something new. And in 1895, Ramsay obtained the first sample of helium on Earth.
Helium is rare on Earth, but the second most common element found in the universe.
So the biggest consumer of helium is NASA. That is because they use helium to cool liquid nitrogen and oxygen for rocket fuel. It's also used in hospitals where they use it to cool the superconducting magnets in the MRI scanners.
Helium is usually found as a byproduct of uranium, and thorium can be found in the underground field in Texas and Kansas, but is currently in short supply.
That's right, guys. They are in short supply. So let's get down to our first experiment of helium.
So it has this helium thing. You can put the point. You can put this side or this side. It doesn't matter. No, except for this I've made it for you.
And it's just like what it says. It's transparent. It's colorless. It's white color to it. Okay. Thank you, my assistant. Next, we'll be discussing
Neon.
neon.
It is the 10th element in the periodic table. Melting point equals negative 248 dot point 67 degrees Celsius, and the boiling point is negative 246.048 degrees Celsius.
So neon was one of the elements that was discovered by Travers and Ramsey. They actually discovered, I think, 2 or 3 more elements in addition to finding neon. They did this by extracting an element from cleaning the or from removing nitrogen, oxygen, carbon dioxide, and water from clean air. And they found each element using their density, by their density. Neon is the 5th abundant element in the universe. It emits bright orange and red light when thousands of volts are applied. Many people use neons for like store signs, but they also use other elements for store signs. So not just neon. The production of neon glass tubes, though, it started in 1910 by Georges Claude. He actually started producing these, and he shaped them and turning them into signs. Okay, now we're about to do neon.
Let's see what it does. It goes bright orange and white in the middle, if you guys can't see that.
Like that. I don't know.
If you, oh yeah, you won't be able to see bright orange. The orange on this is beautiful. Put this back.
Alright, so we're talking about, next will be argon.
Argon has the atomic number of 18 on the periodic table. Melting point is negative 189.4 degrees Celsius, and boiling point is 185.8 degrees Celsius.
It was, again, this is the one of the elements that was found by Travers, but this time it was accompanied by Lord Rayleigh in 1895. They did this in the same method as when they extracted neon. So they removed all the other elements and found argon. Argon is the 3rd most abundant gas in Earth's atmosphere, but this element is most abundant in the Earth's crust. It forms very few compounds. That's why it gets its name, lazy. That is the Greek word argon, is lazy. And due to the fact that it's very inactive, it doesn't really react with other elements. Argon is used in hospitals as argon lasers for treatment of retinal detachment, welding arteries, and destroying tumors. Alright, let's do argon.
You have the argon bottle right here. I'll let you do it this time.
Okay.
So my mom's gonna put the argon near the thing. Be careful again.
Awesome. So right now what I'm seeing is
transparency, kind of white, like white mixed with transparent clear. Boom, it's this color, I guess.
okay, awesome. Thank you.
You're welcome. Very welcome.
Okay, so now we're doing the krypton.
Atomic number of 36. Melting point is 157.2 degrees Celsius, and boiling point is 153 point negative 153.4 degrees Celsius.
Again, this is the element, one of the elements that was found by Ramsey and Travers in 1898. This time they tried extracting this, and they kind of guessed that it was hidden in the argon element. So what they did is they liquefied and they evaporated, and they were able to extract an element that was of heavier density. They actually found krypton by accident. They were trying to extract an element of a lighter density that would fill in the gap between helium and argon, but they actually found krypton. Unlike the lighter noble gases, krypton is reactive enough to form some compounds, such as krypton difluoride. Krypton is used to trap heat as it is sealed between the glass of double pane windows, but argon is usually mostly used for this purpose, since argon is more common. But some people use krypton for this.
Krypton is very, very, very rare in Earth's atmosphere.
Alright, okay.
Let's
Can you do
test
the test of krypton, please?
Another source of krypton. It's exactly like the others except for neon. That's kind of pretty. Don't, and guys, remember, drop it in the container gently. Don't drop it like from on top of the sky. You know what I mean, do you guys? Hope you do.
Okay, so our last element would be xenon.
Atomic number 54. Melting point is negative 111.79 degrees Celsius, and boiling point is 108.12 negative 108.12 degrees Celsius. And mommy, can I please read the this xenon is very, very rare gas. It produces blue glowing light in a voltage Tesla coil. Discovered by Ramsey and Travers, as xenon also was extracted from liquid air. Brightest gas on Earth, but rare in Earth's atmosphere.
It is only present in trace amounts.
Is only present in trace amounts. Unlike lighter noble gases, xenon carries few chemical reactions, forming compounds with fluorine, oxygen, carbon, and many others.
So xenon and krypton, they are more reactive than the other lighter elements in the noble gases. Therefore, they react. They perform chemical reactions with other elements. Okay. Well, we're gonna do the last experiment. Xenon. You want to explain what we're seeing here?
From our view, it's kind of like a greenish, bluish, brownish kind of. It's not exactly like my skin color. it has a lot more brown, but it's kind of like my mom's skin color. But I need to tell you guys, if it touches the wire of it, it goes dark, but it's still on. So yeah.
Well, alright, you guys, that's it for today. Thank you for watching. Have a good day.
Have a good night and sleep tight. Happy Thanksgiving. You can watch it anytime you want. Bye.
Bye.